Now we're going to start working on how to find the area of parallelograms and triangles. Please make sure you have your graphic organizer out and ready to go to help you take notes. Now, first we're going to learn how to find the area of parallelograms. Now, the first shape you see right here, this is a parallelogram. You'll notice it looks very similar to a rectangle, except the sides are kind of slanted. They don't make right corners. The angles on here are not 90 degrees like they are on a rectangle. Now, but we can, if you watch carefully, we're going to turn this parallelogram into a rectangle. And that would be much easier because we already know how to find the area of rectangles. What we're going to do is, if you watch very carefully, if we could slice off this end triangle right there and then move it so that it is over here, guess what shape we just made? We just made a rectangle. So the space that a parallelogram takes up is really the same amount of space that a rectangle would take up with those same measurements. So now that we just learned that the space that a parallelogram takes up is the same as the space that a rectangle makes up, we can decide that the formula to find the area of a parallelogram is the same as finding the area of rectangles. We can still take the length times the width. But when we talk about parallelograms, they have a little different vocabulary. Instead of calling it the length, we call it the base. Now the base could be the distance or the length of the bottom or the top. That is what we would call the base. And instead of saying width, we call it the height. The height is how tall the shape is. So instead of saying length times width, we would say height times base. We do have to be careful, though, on which height we use for the parallelogram. Now, let me change colors here just a moment. I want to point this out to you. If you look right here at this 8 inches, that 8 inches tells us the length of this side. Well, that's great and dandy, but that's not actually the true height of the parallelogram because if you look, it's at a slant. That's not a very accurate measurement. So what we need to do is we're going to use the height, which in this case would be the 6 inches right here, because that goes from top to bottom. So that would be the height that we would use. So to find the area of this parallelogram, we were going to take the 6 inches times the 10 inches, and so the total area would be 60 square inches. Here's your chance to practice what we just learned with the area of parallelograms. I would like for you to find the area of these parallelograms. I want you to first write the equation and then find the area. Now, just to make sure we're all on the same track, let's do the equation for the first one together. If you were to decide the measurements, which measurement are we going to use for the height? Are we going to use the 9 centimeters or the 7 centimeters? Well, I hope you said the 7 centimeters because that one is the accurate one because that's the true height. So to find the area of this parallelogram, we would take the height, which is the 7, times the base, which is the 15. That's going to get us our measurement. I want you to go ahead and complete this page. Pause the video here until you have the opportunity to get the problems done, and then you may continue. Now we're going to start finding the area of triangles. Now, if you were to take two congruent or exactly the same triangles and put them together, you would form a parallelogram. If you look right here, we took an orange triangle and a blue triangle, which were identical, and if you put them together, you end up getting a parallelogram. But if you separate them back into just the orange triangle and the blue triangle, you would really only want half of the parallelogram. We only want half of of the space that that parallelogram takes up. So to find the area of a triangle, you're going to do half of the base times the height. So an easier way to do this is the equation looks like this. You're going to take half the base times the height. Remember, base times height is for the parallelogram, and a triangle is half of that. Another way to write the equation is base times height divided by 2. This is very important with triangles. You still take the base times the height, but you have to divide it by 2 because it only takes up half of the space of the parallelogram. Here are some more examples of finding areas of triangles, and we're going to do these together because I really want to make sure that you understand that we have to divide it by 2. So let's look at that first triangle. The equation, we would still have the base, which is 16, times the height, which is 4. But after we take the 16 times the 4, then we're going to divide it by 2, and that's going to find us our area of the triangle. Now I know you can follow equations, so I'm going to let you find the total area of this one on your own. But let's write the equation for the other triangle. Again, the base is 12, and the height is 9. Well, if we were going to stop there, that's going to give us this entire rectangle. We don't want all of it. We only want half of it. So after we take 12 times 9, then we need to divide it by 2 so that we can find the area of this triangle. Once again, I know you can figure out equations, so I'm going to let you find the final area on your own. Please pause the video here so that you can find the area of these two triangles. Well, here's your chance. You're going to find the area of these two triangles by yourself. Just like the problems we just did, I want you to write the equations, and then I want you to actually find the area. Now that first triangle there is a little tricky. Make sure you use the correct measurements for the height and the base. Now once you get this done, your entire graphic organizer should be completed. It is due tomorrow in class. It is counted as a homework grade. Good job, guys!